Hello everyone, my name is Martin Gazarowski, and I would like to talk about object-oriented databases. The reason I chose this topic, apart from it being the first one on the list that I knew anything about, was the fact that I thought we were talking about object-oriented databases this entire time. I had no idea that relational databases couldn't hold objects, or they couldn't have that they had that kind of limitation. So I just found that interesting. But to give a brief overview, I'm guessing if you're watching this video, you probably know a good amount about software, but just in case. So relational databases hold uh, tuples, which are just like entries in a table. So it just holds a table basically, and the the tuples have attributes that are either strings or integers or something primitive like that. An object-oriented database holds objects, which is an object is a term in software that basically it could be anything. It could hold anything. So if I make an object, I could put it in a database, and it could have a video, it could have pictures, it could have Word files, it could have other objects, which you can keep going and going and going, putting more and more objects into objects. Becomes a little bit more complex, but it does let you store a lot more and different data. So looking at the history of databases, relational databases became popular in the 60s, and they stored things like employee information and like let's say you're doing your payroll, you probably have a database full of paychecks or pay stubs, or employees and their salary and how long they've been with the company, things like that. Or if you're a police station, then you probably have a database full of criminals, and then a separate database or a separate table full of the crimes, and then you'd be able to relate the two. Once object-oriented programming became popular, obviously, if this data set called an object started becoming prominent, then they had to create databases of them to organize them, and that happened during the late 80s. Probably got a little bit more popular in the mid to late 90s when the internet started coming out and becoming a household thing. But still, the relational databases still existed. People still stored things on them. However, as I said, once objects became a thing that people used, they did start having to make object-oriented databases to help with the increasing size of data types, increasing performance of computers, and again, we just need to store more than just strings and primitives. If you look at increasing data types, let's say you wanted to put a movie file into a database. Well, looking at these videos, let's say this one here, it's 6.5 gigabytes. Not only is that not going to work well with just putting it into a relational database, I don't even think it could do that. But let's say it could, and then you wanted to find all of the entries in that database, whatever they were, that had that exact video in it. So at that point, you're comparing two 6.55 gigabyte files to make sure that they're the exact same file to return both of those entries. That's just not something that's gonna work well. Now, again, there's still going to be relational databases. For example, like I said, police departments would have tables of criminals and crimes. And you would think that such a database would be sufficient for the same type of data in today's settings. Looking at a really simple example of that, we could have this database of criminals, and no, I didn't look up their dates of birth. None of this information is supposed to be accurate. It's just illustrative. It wouldn't be too hard to keep a database like this organized, but the thing that you have to keep in mind is that these like for example the crimes, they would have a file ID that would correspond to a physical file in a filing cabinet somewhere in the records department, where they had all the pictures and the videos and maybe some written statement by a witness or something like that. So you couldn't just go off of the database. The database would point you in the right direction, but really the database was more like an organization of where everything's kept. And sometimes you'd have to go to a different police department to find that file, or maybe some other officer is looking at that file. So because it exists physically, only one person can possess it at one time, which having a database full of objects that can hold everything would really help in that situation. All right, so like I said, having an object-oriented database in that situation, looking at the same kind of database like this. I know this is not a database, but you get the idea. Let's say I had a crime object and a criminal object. Then I could just put, private name. Sorry. And once I had that, I could just store a database full of criminal objects, and then the criminal ID would just be the name of the object. I'd be able to search that database and pull everything up a lot quicker. It wouldn't be nearly as difficult to manage something like that. And here, let me just go a step further. And I won't be using that code right now, but I'll get back to it in the later part of this video. Now, anything that has a large portion of engineering, the object-oriented database community has gotten together to come up with an object-oriented database manifesto. So I'll read that to you now. This paper attempts to define an object-oriented database system. It describes the main features and characteristics that a system must have to qualify as an object-oriented database system. We've separated these characteristics into 3 groups. Mandatory, the ones the system must satisfy in order to be termed an object-oriented database system. These are complex objects, object identity, encapsulation, types or classes, inheritance, overriding combined with late binding, extensibility, computational completeness, persistence, secondary storage management, concurrency, recovery, and ad hoc query facility. Optional, the ones that can be added to make the system better, but which are not mandatory. These are multiple inheritance, type checking, inferencing, distribution, design, transactions, and versions. Open, the points where the designer can make a number of choices. These are the programming paradigm, the representation system, the type system, and uniformity. Now, if you're not a software student, you're probably asleep right now. But if you are, then a lot of those terms are really something that you'd be familiar with, just with object-oriented programming in general. So the two aren't really all that different. All right, some added benefits aside from just being able to store large objects. Searches of a gigantic database can be done almost immediately. For example, let's look at this hypothetical crime number 874-29374. So even looking at a really organized system, like let's say the 874 was a specific jurisdiction or area, and then 2 was the department number that would handle that specific kind of crime. You still have 9,374 entries to get through in a standard relational database before you're going to receive that crime file, which again is still not going to be as concise as an object containing it. Whereas if you're looking through a object-oriented database, you type in that crime number and it immediately gives you that number. The ID is just gone. It goes straight to it. It doesn't go through crime 1, 2, 3, 4, 5, and so on until it gets to 9,374, and then to finally give that to you. Another benefit is that security can be enforced at the class level. I'm going to go back to Eclipse here and explain what I mean by that. So let's say the social security number should not be seen by anyone other than someone who really needs to see it, which is true. You can do something along the lines of, where's it get SSN? Instead of returning the social security number, you can say and then I'm not going to import the scanner, but you get the idea. Okay, so I skipped over a lot of things here that are just outside of the scope of the class, but basically it's saying it's going to ask for the password, and then I didn't store an actual password attribute, so that's why it's underlined there, but that person would have a password for their crime file, or for their file, and it would ask you for the password before that. If I just create the object and then somebody else creates a database and throws a bunch of the objects in there, that person's information would be would be out in the open, and that's how it would be in a relational database. All the files, or sorry, all the attributes would be available to anybody that can actually access the database itself. Whereas this, I can say, well, you know, if you want to get the social security number of someone, then you still have to have a password for that. So, you know, I know there's obviously other ways you can protect your databases, but I do think that this is a little bit better, more customizable, I guess. All right. Now, nothing's perfect, so obviously there are going to be some disadvantages to the object-oriented databases. And one of it is really similar to a lot of times when we're in school learning about just the best way to do something. That's not the same as learning about the way people do things. For example, when I first started learning about coding, I was surprised to see all the console applications that were out there. You know, nobody uses those anymore. But then when you look into the industries that we're going into, you know, a lot of people are using really basic input and output things. So, you know, it's not necessarily console, but in the real world, some programs are really that simple. So we do need to learn how to do those. Same with relational databases. If, you know, I could go on for days about how object-oriented databases are better. But given the aviation industry that I'm going into, object-oriented programming isn't even really allowed. It's so heavily regulated that you just might as well not do it. Which, having read the documents, which it's called DO-178C, if you really want to look it up, and it will put you to sleep faster than this video will. Basically, the reason that they don't allow it is because you could do it wrong, which you could also bolt the wings on a plane wrong, but that's another story. anyways, in the industry, the relational databases are really the standard. So if you want to work with them, you're basically either going to have to find a company that does, which wouldn't be that easy, or just start your own company. And if you want to do that, go ahead. There's a lot of tools open out there for implementing object-oriented databases. ObjectDB is an API for Java, so it basically lets you implement an object-oriented database in Eclipse. But really, in researching this, there's plenty of options out there for you. All right, thank you for watching my video. I know you won't be able to click on these on screen, but I'm going to be cutting them and pasting them into the comments section of my video once I upload it.